I'd like to begin by acknowledging that this event and our participants are located on the unceded lands of traditional custodians throughout Victoria, New South Wales, and other parts of Australia. I'm joining you from the lands of the Wurundjeri Woiwurrung and the Bunurong Boonwurrung peoples of Melbourne. I pay my respects to elders past and present, and also extend this respect to Indigenous participants joining us online today. I recognize that we live, learn, and work on lands of the oldest living cultures, lands that have been cared for and managed for millennia, and that First Nations peoples must be central to any decisions about Australia's future. I'm delighted to welcome you to tonight's Ideas in Society event, the Superpower Transformation, with Professors Ross Garnaut and Tim Flannery. This is the 5th event in this year's Ideas in Society program, and the 13th year that La Trobe University Vice Chancellor's Fellow, Emeritus Professor Robert Mann, has presented Ideas in Society. Ideas in Society brings together eminent Australians to consider the big issues facing the nation and the world. Tonight's discussants certainly fit the bill of being distinguished and prominent experts, and they'll be talking about big issues. In fact, they'll consider matters that concern the very future of humanity and life on our planet as we know it. Tonight's event follows earlier discussions in this year's Ideas in Society series that have examined Russia's war on Ukraine, the crisis in Australia's aged care homes, and Australia's handling of the COVID-19 pandemic. And a fortnight ago, Ideas in Society was in Sydney, presenting the former Australian Prime Minister Paul Keating in a wide-ranging discussion about Australia's relations with China and the United States, the AUKUS Treaty and our nation's defences, the monarchy and Australia's head of state, and much, much more. After tonight, there'll be one more Ideas in Society event this year. In November, Cathy McGowan, who is also a La Trobe University Vice Chancellor's Fellow, will moderate a discussion on the role of the Greens and Teal independents in the newly elected federal parliament, with Adam Band and Max Chandler-Mather from the Greens, with Zoe Daniel, a Teal independent, and Simon Holmes-A-Court, the founder of the Climate 200 initiative, and who supported the election of several Teals to the House of Representatives. I don't think Rob has curated a more important series of discussions in the 13 years he's presented Ideas in Society. It's been a terrific program, and he merits recognition. But now to tonight's event. The promotional blurb really said it all. To quote, join Australia's most influential, original, and forward-thinking economist, Ross Garnaut, and our most eminent climate activist, scientist, and author, Tim Flannery, in a conversation concerning the future, not only of Australia, but also of humankind. There are also two things that are particularly pleasing about tonight from a La Trobe point of view. First, Ross and Tim will be discussing two of Ross's books that we've published with La Trobe University Press and our publishing partnership, Black Ink. We're very proud to publish Superpower, Australia's Low Carbon Opportunity, in 2019. To say that it was influential is definitely an understatement. Sometimes important books sell only a handful of copies, but if you can publish something that's read by policymakers and also sells a lot of copies within the broader community, you get your message out to that many more people and have that much more impact. Superpower sold 20,000 copies, making it a staggeringly successful nonfiction work in the Australian market. Of course, we're here tonight to also talk about the follow-up to Superpower, the Superpower Transformation, making Australia's zero carbon future, in which Ross presents practical steps to bring the ideas in Superpower to life. Professor Ross Garnaut is an economist, a fellow of the Australian Academy of Social Sciences, a distinguished fellow of the Economic Society of Australia. He's founding director of both the Lowy Institutes and the International Policy, the Lowy Institute of International Policy and AsiaLink. Amongst other roles, Ross has been the senior economic advisor to Prime Minister Bob Hawke, Australia's ambassador to China, chairman of the Primary Industry Bank of Australia, and chairman of Bank West. He's led numerous government reviews and commissions, including the Garnaut Climate Change Review in 2008. Ross is not one to sit idle. He wrote another book that we published with La Trobe University Press last year, Reset, Restoring Australia After the Pandemic Recession, which he wrote under pandemic conditions. And after he gave a widely quoted keynote speech at the Jobs and Skills Summit hosted by the Prime Minister and Treasurer last month, he's continuing to have an impact. You can see why Ross Gittins calls him the nation's most prophetic economist. I said there's a second reason why La Trobe is so pleased to bring Tim and Ross together. And it's the fact that Tim is a La Trobe University alumnus. So welcome back to La Trobe, Tim. Professor Tim Flannery is one of Australia's leading writers on climate change. He's been a professor at the University of Adelaide, director of the South Australian Museum, principal research scientist at the Australian Museum, and visiting chair in Australian Studies at Harvard University. Tim is well known as a radio and TV presenter and was Australian of the Year in 2007. His latest book is The Climate Cure. Tim will talk to Ross about superpower transformation, and then we'll have time for our audience to submit questions. So please think about the questions you'd like to ask. It's now my great pleasure to hand over to Tim to get the discussion underway. And thank you.
Thank you so much, Susan, for that great introduction to country and overview of what we're doing this evening. And Ross, it is such an honour to be back with you, particularly with this important book, kind of vitally important book, I think, for our nation. I've spent the last few days thumbing it very diligently. The message is very clear. I think it's a beautifully written book, if you don't mind me saying. I know you wrote chapter 1, Ross, and edited the rest. It is clear and urgent. And I just wanted to begin, Ross, by asking you why you chose to publish this particular book at this particular time.
Well, Tim, I wrote Superpower, which the Deputy Vice-Chancellor has mentioned, published by La Trobe and Black Ink back in 2019, and that laid out the general idea, the conception of Australia having big advantages in the zero emissions economy, which if we really took advantage of them would see us move quickly to zero emissions ourselves, but develop new industries embodying zero emissions energy and zero emissions raw materials, which would be new export industries. In this book, Superpower Transformation, it's a more practical, nitty-gritty look at exactly what we do and how we do it. And it's an edited volume, as you've mentioned. I've got a long essay at the beginning, bringing it all together. And then I've got chapters by deep experts in a number of the important fields. There's Multi-Meinhausen on the atmospheric physics, saying really up-to-date research on how we're going on holding temperature increases to 1.5 degrees, what more we have to do. The basic lesson there is we all have to go a bit faster than we think we have to. But it also says that it's manageable, it's possible. We just have to take the opportunities we've got to go faster. And then Mike Sanderford, a long-term Dean of Sciences, Professor of Geology at Melbourne, brings together the story of all the energy transmission minerals that are going to be needed to produce the machines of the new economy, and how Australia has spectacular advantages in doing that. We've got more resources for those industries than anyone else. And Mike's last few pages are rather sad for an academic in Australia. It tells the story of the decline of the intellectual base for this applied science, including his own earth sciences and geology, in fields relevant to the superpower transformation over the last few years, when we gave JobKeeper $250 million to the casinos and nothing to the universities. We really showed our government's priorities in those days, but it's left us with a weakened intellectual base for all the brain work that has to be done to make this happen. The wake-up call there. Then Frank Gotzo, Professor of Economics and Professor of Climate Change at the ANU, a chapter on hydrogen. Professor Li Gang-sung, again at ANU, Professor of Economics, heads the China program, on a very practical chapter on how the world's not going to get to zero emissions unless Chinese industry is decarbonized. Chinese steel industry alone accounts for 4% of world emissions, just turning iron ore, mostly from Australia, into iron metal. And it happens that that's going to be very hard for China to do that from its own renewable energy resources. It needs its renewable energy resources to decarbonize other things. It can get a lot of help if we use our renewable energy to turn our iron ore into metal, not only for China, but the same story. Maybe it'll happen more quickly with Korea, Japan, Germany, other industrial countries. A chapter by one of my colleagues in the renewable energy company, Zen Energy, Isabel Grant, on the opportunities for landscape carbon. Australia's a wonderful opportunity to restore carbon in soils and plants, and then do more using the advantages of native Australian species for absorbing carbon in a variable climate. And then another one of my Zen Energy corporate colleagues, Susanna Powell, looking at a case study of how you can use renewable energy resources in rural Australia to develop jobs and new centres of dynamism. So it's a highly practical book showing us how to do it. And I bring that story together, and the bottom line is that we can not only bring prosperity to Australia if we use this opportunity, if we go fast on developing the zero emissions industries. Of course, we could go slow and miss the chance, but if we go fast and go quickly to zero emissions ourselves, we can be a huge help to the rest of the world getting to zero emissions. And with some fairly rough and ready arithmetic, I demonstrate that we could reduce global emissions by 8% through what we do ourselves, 1.25% by ourselves going to zero emissions, but another 7% by supplying zero emissions goods to the rest of the world, that the rest of the world, especially the densely populated industrial regions of Northeast Asia, Japan, Korea, China, and Europe, that we can supply them with materials that they'll find it quite hard to generate themselves from renewable energy. So that makes us quite a big player. That makes the direct contribution we make, twice as big as the whole of Europe, including the UK, going to zero. Several times as important as Japan going to zero, more important than India going to zero. What happens and not only is it 8% of global emissions being removed, but it's what for a lot of other countries would be very hard emissions going to get to zero. A lot of these industrial emissions, it'll be hard to get rid of in Germany or Scandinavia or France or Holland or Japan or Korea or China. So it shows that what we do will have quite a big effect on whether the world succeeds in dealing with this problem. So why did I write this book now? Because new research over the last 3 years allows us to quantify and spell out in a very practical way an immense opportunity. It happens that the publication of the book coincides with a big political watershed in Australia. I think we do have to see the last election as something more than just the toing and froing between Labor and the Conservatives that's gone on for 110 years.
Just jumping in there, Ross, if I could, sorry, just you're absolutely right about that. And, you know, I think you've outlaid beautifully how large this transformation is. The challenge of it is enormous, as is the opportunity. In that light, how would you characterise the past decade in Australia?
Well, it's one of policy incoherence. I wouldn't go right back a decade, actually. From 2012 to 2014, it was deeply contested, and it was the subject of bitter public debate and dysfunction. But we had in place a set of policies that were genuinely world leading. The Gillard government and the Hung Parliament legislated them. We had a carbon price. We introduced new institutions to support the transition, the Australian Renewable Energy Agency, the Clean Energy Finance Corporation. We introduced credits for carbon farming, which could be sold to companies that were liable for carbon credits. All of that worked brilliantly. I've been involved in a lot of economic policy reform in the past 50 years. Usually things don't go exactly as all the modeling says they will, but that went very smoothly. We were reducing emissions at a rate which, if it had continued, would have had us zero in 2050. Well, only last 2 years, but at least it showed that we can do it. But then really from the time that Tony Abbott wrested the leadership of the Liberal Party by a single vote from Malcolm Turnbull in December 2009, we had the Liberal National Party coalition really contesting the idea we had to deal with this problem. By the way, contesting our making use of an immense opportunity, especially for rural Australia, but that was the reality, and so we had incoherence. One product of that incoherence is that we really got badly out of step with countries abroad that we need very good relationships with. We were right out of step with our North American friends, the United States and Canada, once Biden became president. We're right out of step with the European Union and Britain. We're right out of step with Korea and Japan. We were tragically out of step with the South Pacific countries that are so concerned about what for them is an existential threat of climate change. So we mucked around, and if that had continued much longer, we would have lost a great opportunity, as well as made it much less likely the world will deal with this serious threat to Australia and neighbouring countries.
Sure.
But I think that's, yeah, I think that we're coming away from that now.
Great. Look, thanks, Ross. Could I now turn to the issue of green electricity or clean electricity? Because I think that lies at the heart of your vision in a way. If we don't have that clean power, we won't be able to realise the vision. And I just want to ask you about the scale of the challenge, what the national vision is, because you talk about that, or should be. But just first reflect on what's required even to green our current electricity requirements. So, we know we've got to double our solar, triple our wind. The poles and wire network has to grow 24 times. That's a huge job just in itself. You're pretty close to the ground. This is a how-to handbook. So just two things, Ross. How do you see the installers, the people who are responsible for this work? What's their view on the feasibility of scaling up so rapidly? And how are we doing in terms of your vision? Are we doing enough? Do we have much to go? We're going to have to ramp up 3 times. Where do we sit?
Well, we're at a big disadvantage, Tim, because the planning wasn't done for a truly zero emission economy. So anyone who looked at what needed to be done, when you and I were writing about these things a decade ago, knew that we had to do a lot of new things. We needed a new a system of power transmission to link rural areas with wind and solar resources to the big centres of demand. There are a whole lot of things that needed to be done. We needed a new system of planning. We needed to change a lot of regulations in ways that supported the new technology. And we found that very slow going. And the fact that we have been slow going means that we're a long way behind, not only in building the superpower, but even in doing what we need to do to get to zero emissions ourselves. But in the last couple of years, we've actually slowed down because we used up a lot of the transmission capacity and a lot of the best places for putting solar and wind didn't have any more transmission capacity. For example, in Victoria, the best wind resources are out in the west and the solar in the northwest. But years ago, all the surplus capacity in the transmission lines were used up. A lot of people invested in those areas in wind and solar and couldn't connect. It came to be known as the rhombus of regret. The big challenge was simply facing up to the reality that we had to do it. Once you realize A, that you have to do it, and B, there are huge benefits in doing it quickly, then it becomes feasible. I picture a sentence from Shakespeare to explain the situation. The barriers are not in our stars, but in ourselves. It's ourselves realizing that we have to do it, that's been the barrier. And let's get rid of that, then we can do it reasonably quickly.
Indeed. And I venture to say, Ross, that the small diagram you included in the book that shows what the interconnector should be across the continent will be one of the most influential things that the book will deliver us. It's a beautiful diagram. You let your imagination run free as to what that means, and you see a different country.
But, yeah, and I've had lovely feedback from that, from West Australia, Queensland. So it's already getting a fair bit of discussion. That's Appendix 1 too.
Good, indeed. Look, can I just now turn to minerals processing, Ross? You know, you have a great table in the book which ranks the critical elements and where Australia's reserves stand. So could I just run through that? Australia ranks in first place among the critical elements for iron ore, aluminium, zirconium, zinc, and tantalum. We're second place for lithium, manganese, and cobalt. Third place for titanium, vanadium, copper, and tin. So when you think of the possibility of processing all of those minerals here in Australia, I mean, that is a massive, it's a supersized opportunity, surely. But could I just to really get into it, I'd like to go to iron ore first, because I think that's probably pretty close to your heart, Ross, and there's a bit of time in the book delivered to that. Could you take us through what it would mean to the country to be processing its iron ore in within our boundaries, within our borders, and how we might go about doing it?
Well, I've got a confession to make, Tim. I grew up in West Australia, and as a schoolboy, used to read. Sounds rather incongruous, but as a schoolboy, I used to read the Hansard statements from Charlie Court, the Minister for Industrial Development, about this new iron ore industry. And it was always a condition the West Australian government put on access to those the world's best iron ore, that a proportion be processed in Australia. Well, the companies took no notice of that, and we're never all that strict on enforcing legal obligations if very big companies involved. So that didn't happen. But from the days growing up in WA, I've taken an interest in these things. At the moment, we're by far the world's biggest supplier of iron ore. China, the biggest market. We ship out the iron ore, and wherever it goes to, it's joined with carbon from coal in blast furnaces. For those who remember their high school chemistry, iron ore, iron oxide, Fe2O3, Fe3O4 is combined with the carbon pulls out the oxygen atom, leaves the pure iron metal. And what it pulls out, the carbon joins with the oxygen, is carbon dioxide. And as I mentioned before, 7% of total world emissions are the carbon dioxide from putting coal into alongside the iron ore. That's how we do it now. Now there's another way of doing it. You reduce iron oxide to iron metal. You can reduce it with carbon, but you can also reduce it with hydrogen. And the big difference is if you use hydrogen, instead of getting CO2, carbon dioxide, you get H2O. And so the waste product is water, and water is not a pollutant. You could capture it and use it if you're in a place that needs it, or you just let it go into the atmosphere and it won't do much damage, won't do any damage. It's technically quite possible to replace one of the world's most polluting industrial process by a clean process. You have to use green hydrogen to do that. Hydrogen made from renewable energy. You can make hydrogen from coal or gas, but that has a lot of carbon emissions along the way of producing hydrogen. People say, well, you could capture that and bury it underground. Well, you could, but it costs a lot of money, and that's why no one's doing it. If anyone starts doing it, we'll take it seriously, but it's not being done at the moment. The places that are the natural places to turn iron ore into iron metal in the zero emissions world economy, the places that have got iron ore and cheap renewable energy. And there's that one place.
That's right. It's Australia, isn't it?
That's us. And and I say, if we turned our iron, I think I used it for the arithmetic, turned half our iron ore into iron metal, and a proportion of that, a sixth or something, all the way into steel, again using the extra input is more electricity, which can be renewable electricity to turn iron into steel. Then we would double the value of our iron ore exports. Iron ore is by far our most valuable export. Depends on the price, of course, but these recent years, about 30% of our exports. Well, we could double that with the processing in Australia, be more industry in rural and provincial Australia. Not necessarily all where the iron ore is. You might shift some of it to other places with good ports and renewable energy. And we'll be doing it in Australia and not, one might say, why don't we do it now? We're using coal in Australia because we're the world's biggest exporter of coal. A lot of the countries, especially Korea, China, that import our iron ore also import our coking coal and make the steel. So why don't we do that now? Well, the economics don't favor it particularly because it's very cheap to put coal on a boat, and it costs us, Queensland coal costs more in Whyalla than it costs in Japan or China. It won't be like that with hydrogen or electricity. You can export hydrogen, and we will. You can export renewable electricity in cables, and we will. But it'll cost more than twice as much in the destination as in Australia. Quite unlike coal, where it costs very little more, sometimes less in the other countries.
Exactly.
So it's a natural industry for Australia.
Right. Look, if I could just say, Ross, a lot of people seem to see this prospect of using the DRI technology, direct reduction using hydrogen, as being quite distant. But I just noticed that ThyssenKrupp, which is the world's third largest steelmaker, announced last month that they were they'd put out the contracts for a 2.5 million tonne per year DRI plant that'll be fully operative at Duisburg in Germany by 2026. And that is soon for that sort of investment.
Yeah, I've mentioned that, and I mentioned the acknowledgements of the book, that I'm on the board of Zen Energy, which is a zero emissions electricity and hydrogen company, and we're working with some companies and we think that at current coal prices, which are high at the moment, even without any recognition of the quality of being green, it's economic now. Now people, an investor would worry, well, maybe the coal price will come down when we've got peace in Ukraine, or people prepared to trade with Russia again. Maybe it will, maybe it won't. But right now, it would be cheaper to build a fully in a good place like Australia with good renewable energy resource. It'd be cheaper to do clean hydrogen, use direct reduction techniques to make iron. And if you take into account the value of it being green. For example, if you impose a carbon price at the level the Europeans have, then it's overwhelmingly more profitable right now to do it. And we won't be able to export a lot of products to Europe or America or Japan or Korea unless we either pay a carbon price at their borders or send green things. So we're going to be under a lot of economic pressure to do it relatively soon. The dreamers in business think they can just sit on their backsides and keep doing the things the way they're doing it now for another 2 decades. I think that zero emissions by 2050 means doing something in 2045, but they're going to be pushed into much earlier movement.
That's great to hear, Ross. It's fantastic. Could I now, I just want to focus on hydrogen a bit, and perhaps as a way into it, just to have a think about Boston Metals, you know, the US-based steel manufacturer that's they're a startup at the moment, but they're producing iron without using hydrogen. So it's a purely electric process. And it just made me thought, is there too much hype around hydrogen? Do you think that other processes or direct use of electricity in various areas will overtake the hydrogen bubble or the hydrogen hype?
Well, I am in favor of us experimenting with every promising technology, and I think that institutions like ARENA should be systematically supporting anyone having a go with a zero emissions technology that's got a reasonable chance. Not purely fanciful things, but if someone like that Boston group's doing it, well, we should be providing fiscal support for that. There's a strong economic case for support for innovation as part of standard economics. And the reason why it's worthwhile the government supporting innovation is that the first movers in any new process, any new technology, any new industry discover a lot of things. They develop a lot of knowledge that everyone benefits from. They make a lot of blues. Whoever does it first makes a lot of blues, and everyone learns from that. And so it's worth the community encouraging those who are prepared to have a go, and research, development, commercialization. There's a strong economic case for support. So I'd support the use of electrolysis, electricity alone to make iron from iron oxide. But just at the moment, we have direct reduced iron techniques. They were developed for natural gas, but you can use them for hydrogen. We've got them working now. Yep. One day we might have electrolysis techniques. One day they might be cheaper, and great, give them a go. And if they are, that's fantastic. That we might have 2 different horses for different courses, or one might win. But right at the moment, hydrogen's the low-cost way of getting green iron. Let's grab that opportunity and also give a hand to anyone trying to develop something else that might be better.
Yeah, look, that's exactly how I see it, Ross, as well. I think you've just explained that extremely well. I guess I didn't mean to suggest that hydrogen was being overhyped before, just possibly, you know, when you see some of these new technologies, I guess there are questions being asked. But at the broader level of what we actually export, you know, there are it seems to me, 2 rapidly consolidating schools of thought. One is the Twiggy Forrest view that we'll be exporting molecules of hydrogen or something that carries hydrogen. The other is the Mike Cannon-Brookes view that no, we'll be using HVDC subsea cables to be exporting electrons. Now, I know that the HVDC cables seem a long way off, but I've just read a wonderful book, Ross. It's Werner von Siemens' autobiography, and he talks about developing undersea cables for telecommunications and how impossibly difficult it seemed in 1870. I mean, unbelievable, off a sailing ship with a cable going to water 2 kilometres deep. No one had even thought of using rubber to coat them. I mean, you know, it's just a long way off. But within a decade or so, they were everywhere. So I don't want to write off the HVDC cables. I just wonder how you see it. I mean, will it be electrons? Will it be molecules? Will it be a bit of both? What's the vision?
It'll be both of them. But for Australia, even bigger will be products embodying zero emissions renewable energy. And it will be all of them, but get me to guess, and I'd guess they'll all be big. The biggest will be products made from zero emissions electricity. The second biggest will be hydrogen, probably more turned into products that embody hydrogen in a form that can be reversed at the other end, like ammonia. You can use green hydrogen to make green ammonia, and at the other end you can reverse the process and get the hydrogen out. That's probably cheaper than liquefying hydrogen and transporting it the way we liquefy natural gas. Natural gas, methane, liquefies at about minus 153 degrees. You won't liquefy hydrogen until minus 253 degrees, almost absolute zero. And the closer you get to absolute zero, for kids who paid attention in high school physics, the closer you get to absolute zero, the more energy you need to get it a bit closer. So you use more than half the energy in hydrogen to liquefy it. And then the other trick with hydrogen is it's the smallest atom and the smallest molecule. If you just use standard steel, so small it seeps out between the molecules of steel. And so you need special materials. It can be done, it will be done, but it's expensive. So probably more embodied in ammonia and other products, and the hydrogen taken out the other end. But both those things will happen. Subsea cables, high voltage, direct current, already there. We've already got that cable from Tasmania to Victoria, and it works fine if something doesn't happen to break the cable. And then it takes you a fair bit to find out what happened.
As Werner von Siemens knew, it's horrifically difficult at the start. But
the technology is already there, but it's expensive.
Yeah.
But the Cannon-Brooks Forest project to take a submarine cable to Singapore, I reckon that will probably happen. And they're planning it to supply 15% of Singapore's power needs. How magnificent! And if you do that, then you can send a bit of a spur to Java. Java's short of power. And once you're in Singapore, you're just the Johor Strait, just a kilometre from the Asian mainland and into the grid there. So that'll be part of the picture. But where the economics are strongest is using renewable energy to convert Australian materials into products so that you don't have to use renewable energy for the processing in other countries where it's much more difficult, they don't have the space, and much more expensive.
Yeah, indeed. But just to go back to that project you were outlining about HVDC cables, the more they spread, the less darkness there is in the world, really, because the sun's always shining somewhere, Ross, on the planet. The less storage you need, the less intermittency problems you have. There's a big objective there, the big reward, if you get that right.
That's right. Once you get to Singapore, you've got in solar time, the time the sun's overhead, getting from Brisbane in the east to Singapore, you've probably got about 4 hours extra daytime.
That's right.
Early start in Brisbane and a late finish in Singapore. Take it a bit further across the water to India, and that's much shorter than Darwin to Singapore. Then you've added a couple of hours, and then you're deep into the Asian mainland.
That's right. Very interesting. But look, Ross, could I just, we're talking about the vision way out there at the moment. I just want to come back to where we are really and talk about transitions. I mean, it seems to me that transitions are inherently uncomfortable, even dangerous, difficult. And things like the Ukraine war have perhaps brought it home to us perhaps a bit more, transparently. How do you see this transition? Do you think we're going to power through it? Is it going to be difficult? Is it going to be disruptive? What's the shape of the transition, say, over the next decade? How long will it be, indeed?
Yeah, well, obviously it depends on the politics. At the moment, the major countries that are most important to this are in a similar space. the US, Canada, Japan, Korea, China, the European Union, the Scandinavians, Britain, UK, and a fair bit of the developing world. Russia, at Glasgow, there were a few standouts getting in the way of transition. The most active standouts against progress were Saudi Arabia, which of course wants to keep value for its oil, Russia and Australia giving a vote, usually cooperating with Russia and Saudi Arabia to stop progress, which really got President Biden cranky because he thought that we were America's ally and friends, and on an issue that he thought was tremendously important, we were lining up with Russia and Saudi Arabia. But anyway, that's water under the bridge. At the moment, there's a lot of momentum in the world. The Russian war in Ukraine, as you said at the beginning, it initially raised some questions about which way we'd go. The Europeans, they face a dreadful dilemma. They're heavily dependent for coal and gas on the Soviet Union, and the supplies being cut off. And there were voices in Europe that said, oh, we've made a mistake on being too reliant on the combination of renewable energy in Russia. If we kept more of our coal mines, we'd be in a better shape. And there was debate about whether going forward was better or going back. And those wanting to go forward won. So it now is pretty clear that the Ukraine war and the high prices of coal and gas as a result of the Russian dislocations is going to accelerate the transition. Now, the international scene could go backwards. There are bitter divisions over this subject in the United States, like there were for a number of years in Australia. It's possible that leaders could emerge in the Congress and in the presidency in powerful positions in the United States that seriously changed America's position. Trump tried to get the US out of the Paris Agreement. It's actually quite complicated diplomatically, and so he only succeeded right at the end, and so Biden was able to reverse that before it had done much damage. But one can't rule out that possibility. But one thing that's now more and more widely understood is that for large parts of the world, certainly including Australia and North America, the transition involves mainly economic benefits. And so those wanting to turn the clock back are fighting the economics as well as the physics, the atmospheric physics. And it's a more even fight when you've got economics on the side of the science. So I think there's a fair bit of momentum, but one can't rule out the possibility that the politics could go bad again, especially in the United States. I don't think they'll go bad in Australia. David Littlemore's leader of the National Party has been much more positive about the development of zero emissions industry, renewable energy than his predecessors. And the electoral landslide in favor of people favoring the rapid transition to zero emissions was so strong. What happened with the Teals and so on, I think makes it electorally difficult for any Australian political leaders wanting to turn the clock back.
Great. If I appear strange, Ross, it's just that the sun has found a little chink between the trees and is ruining my lighting here. But anyway, look, just reflecting a little bit on that global picture, it seems to me that at least there are some instances where dictatorships are, there's a between dictatorships or oligarchies and fossil fuels, and that democracies seem to be pushing strongly for clean energy, distributed energy, if you want. Do you think there's a danger in that? Will we see a world divided between an old fossil fuel loving lot of oligarchs and dictators and a democratic world?
I don't see the world that way, mainly because the biggest and most powerful of the, we'll use the term autocracy, is a reasonable term, is China. And
Yes.
China is actually committed to the energy transition. It's not easy for China. About half of all of the solar and wind and renewable energy being installed in the world is being installed in China. And about half, more than half of all the equipment for solar and wind is being produced in China. But they're deep into the transition. That's not so obvious when you just look at what's actually happening to total emissions, although Chinese coal use peaked in about 2013, 2014, and has stabilized since then. Before that, it was doubling every decade. Global emissions grew enormously from the turn of the century to 2014. The biggest element of that was Chinese coal use, more than doubling. Well, it stopped increasing. And why it stopped increasing was a little bit changes in the structure of the economy, deliberately pursued by the government, but also because the scale of renewables started to become important. It only really started in China about 2012, 2013, and it's grown very rapidly every year since then, initially from a small base, but now the base is big enough for 30% growth to really make inroads every year into demand. And when you've got a coal plant sitting alongside a solar or a wind plant, you'd take the electricity from the solar or the wind, because it costs, the sun and the wind don't cost anything. But to feed the coal plant, you got to mine the coal. It costs a lot of money. And so as the scale of solar and wind increases, continued rapid growth of renewable energy will eat quickly into that coal base. So we're going to see a relatively rapid transition. And China's not doing this simply because it wants to be a good global citizen. There's a lot of good science in China, and Chinese scientists have pointed out China is very vulnerable to climate change. You get deglaciation of the Himalayas, and you destabilize all the great rivers of China, the Yellow River, the Yangtze, the rivers flowing south. All those rivers have depended for 12,000 years on the steady accumulation of snow in the winters, and the steady release of that through the spring and summer. And if heavy deglaciation destabilize all that, very disruptive. North China Plain, like southern Australia, changes in wind patterns as well as drying will become much more difficult for agriculture. And a very large part of Chinese industrial production is very close to sea level on the river deltas, including great cities like Shanghai, Guangzhou, Tianjin. China has got a very strong national interest in doing something about the problem.
Indeed. I remember reading, Ross, that if we reach 2 degrees C above the pre-industrial average, I think the figures are that 94% of Shanghai will be underwater by 2100. So there's a strong impetus there to move on. Look, could I just ask you about Australia, Ross, and what's happening with rooftop solar? Because it seems to me that rooftop solar, electric vehicles and home batteries are changing the nature of the energy market in Australia. Would you like to just give us a bit of a thought about what's happening in that space? And then what's happening with industrial energy? Who should be paying for the big deployment of industrial energy we'll need in future?
Yeah, well, there's really two different stories. One is decarbonisation of what we've got. Supplying existing households, existing industry in the existing cities. Now, for that, solar on rooftops has done a bigger job than any of us imagined. It's just gone rapidly, more rapidly in Australia than the rest of the world. I think a little bit of that is Australians saying to governments, well, you may not think it's important, but we do. We're going to do it. And then battery costs have come down enough so that it's now it depends on individual circumstance, but a lot of circumstances profitable to have more solar than you use when the sun's shining and store it up for the evening. But the big story, as you mentioned, is electric vehicles. The average household uses 8 times as much energy in their car as they use in their house. So if you put much more solar than your house needs into your put the surplus into your car battery, then that's available to use when the sun goes down, and that can easily, if most of us have electric cars and then feed that after the sun goes down, that can keep the whole of Sydney and Melbourne and Brisbane and Perth and Adelaide running through the night. The quantities are huge. So it's a big part of the story. AEMO, our market operator, does an integrated system report from time to time, and their latest estimates of how they see the future see more than half the storage needs of the future, so that we've got power at night when the sun's not shining, coming from the batteries in cars and households. That's a big story. We have to do a lot to make the distribution systems for power more friendly for distributed use. And that's been hard work because people in the industry haven't wanted to change, but we're gradually getting there. And this year we've seen quite radical change in the mindset, not yet in all of the regulations, but at least recognition that it has to be done, and it has to be done quickly. For the new industries, the superpower industries, which are going to be much, much bigger in the power that they use, I think that's going to be, first of all, most importantly, in the old centres of coal power generation. All those wires that used to take the power out from the coal generation system to everywhere will bring renewable energy back. So there'll be fantastic places to have new industry based on renewable energy. Those coal mining and power generation towns have strong industrial cultures. People don't mind if a new factory starts up and makes a little bit of noise and a bit of stink, whereas try to put that in Brighton or Manly, and you'll quickly run out of town. So that's where it'll be easiest to get started. You've got the existing infrastructure, the industrial culture, lots of relevant skills. But then we'll see new industrial towns develop, and a lot of decentralized small town industry. The economic geography of Australia will change. It'll be terrific for employment in rural and provincial Australia.
So there's hope for Lithgow yet. Well, that's good to hear. Now, can I, Ross, just, I'm going to ask you one more question, and then I'm going to go to questions from the audience, because there's a number of fascinating questions coming through. In your book, you talk a little bit about nuclear options for Australia. Can you tell us how that technology might fit in?
Yeah, well, I first looked at this when I did my big review, which was published in 2008. Initially done for all the state governments, and then the Commonwealth joined when Kevin Rudd became Prime Minister. And then it looked as if, looking ahead, there was a role for nuclear on the pure economics, probably in the 2030s, when we had to put in, when we were retiring most of the coal and need a new source of baseload power. The big thing that's changed since then is the cost of nuclear hasn't come down, but the cost of everything else has come down, solar and wind and batteries. And now, just on pure economics, it's much cheaper to provide power 24/7 through a combination of solar and wind and batteries, or pumped hydro in those places that have the hills to do that. So on purely economic grounds, there's not much role for solar. I do recognize that you never know with technologies. There might be some great breakthrough, fusion technology for nuclear, which incidentally gives you less risk of the material being used for weapons, which is an advantage over the current nuclear plants. And that might one day be cheaper. But a lot of work was being done on it. especially in China and India, when I was doing my work in 2007, 2008, it's still being done on it. Maybe like Brazil, nuclear energy's got a great future and always will have.
That's right. Yes, I think I remember hearing someone saying fusion always seems to be about 20 years off, no matter when you talk about it.
I don't rule it out if
No,
if you do get that technological improvement, and I even point out where you'd put it in Australia if you had it in that big grid you pointed to.
Right.
Joining all
indeed.
parts of Australia. There's a place in South Australia, way out in the desert for it.
Yeah, indeed. Now, Ross, we've had a question from the audience about the carbon implications of digging up all of these critical minerals, such as lithium. Would the amount of fossil fuels that go into mining those minerals really offset the benefits we'd get from processing them here in the country?
Not if our mining's done with zero emissions technologies, and they can be. Twiggy Forest is a marvelous thing, bring all that iron ore down from the hills of the Hamersley Ranges to the coast. It's downhill run, and he's going to use that to generate batteries to run the train back up again. And there's no mining equipment you couldn't run on batteries or hydrogen. And whether it's batteries or hydrogen will depend on cost and technological improvement. There's actually a lot of advantages in using electric vehicles underground. You create fumes and particulate pollution that's very damaging to the lungs of miners working underground. If you're using a battery, you don't have any of that. So there's a safety, an occupational health and safety reason for making the transition. And in the processing, we've already talked about how you can process it with. So what we've got to do is make sure that mining moves quickly to zero emissions, and then we won't have to worry about the carbon in mining the new materials.
And some of them, I remember just reading recently about Carrapateena Oz Minerals, who are their old diesel trucks they used to transport their ore, about 400-kilometre run. It's actually cheaper for them to put batteries in and to recondition the engines. So they're just making them all electric, and they swap the batteries out at the end of the run and run it back. It's one of the most profitable, almost, of their green enterprises. So it's,
and more mining companies are recognising that, and quite big efforts being put into it by a number of Australian mining companies.
Yeah, indeed. Now, we had a question, so it's just gone to the top. Here we go. As we approach tonight's budget, Ross, what are your recommendations for Australia to become a superpower in renewables and in minerals processing? Do we have the vision and leadership?
Well, I think our government's promised us that it's not going to solve all our problems tonight. That's one promise made during the election campaign, and one promise that it'll keep. Not to deal with a lot of our problems, but it will deal with some. And I think especially just from what's been leaked so far, we'll find out later tonight. But from what's been leaked so far, there's quite a lot for renewable energy and the transition. A lot of this was in the government's election program. But I think that those commitments, quite a lot of money to improving the transmission links from the areas of good renewable energy in every state, from Dubbo and Armidale down to Newcastle in New South Wales, from the west of Victoria into Melbourne, the links between Tasmania and the mainland. South Australia's got programs on that the Commonwealth will support. Queensland's very ambitious new energy plan will have Commonwealth support. West Australia, very ambitious phasing out of coal by 2029. We'll need lots of transmission support. So we'll see a lot of that in the budget, and plus support for new programs of community batteries and other things. None of this is a surprise, but it adds up to quite a change in momentum. The lots more change needed, and the Treasurer has told us to look at future budgets for that.
Indeed, that's great. Look, could I just return to the mining issues here, Ross? We hear a lot of talk about drawdown. It's an area that I've been interested in for a long time, and a class of rocks which are very abundant in Australia called silicate rocks. Now, the highest quality of those rocks, if you mine a kilogram and ground it up, you can sequester 1.5 kilograms of CO2. So, and those rocks also, they bring fresh minerals to agriculture. So there's been some trials that have shown you can get a 10 or 20% enhancement in crop yields for corn in the south of the US using those minerals. But how do you think as an economist we might unlock that potential, both to draw down CO2 and to really give our agriculture a bit of a boost while we sequester? And take it broadly, Ross, you can go across all kinds of sequestration in the agricultural sector if you wish.
Yeah, I'm very interested. I'm very interested, as you know, in the technologies of these things, and I actually don't know the silicate story. So you can send me something on that.
Sure.
But generally, the absorption of carbon into the landscape in one way or another is a very big story. This is recognized by the Academy of Science in Europe, the National Academy in the United States. They see that a significant part of the reduction of net emissions going to the atmosphere necessary for net zero coming from landscape carbon. But then once we get to zero emissions, say we got there in 2050, zero simply means things stop getting worse. It doesn't take back any of the warming that's happened before. Things will keep getting worse till we get to zero, and they just stay the same once we're at zero. I have little doubt that our kids and grandkids, our grandkids more than by then, when they get to 2050, will say, what was Granddad thinking when he thought that it was acceptable to have 1.5 or 2 degrees of warming? The world was much better for humans the way it used to be, and they'll want to take carbon out of the atmosphere, and there's a lot of potential for absorbing carbon into soils and plants, and generally you improve the productivity of soils and the water retention, the fertility, if you have more carbon in it. One of the problems of farming in Australia is we've depleted old carbon stocks, and that has reduced the fertility of the soil. Just restorative farming and bringing back the carbon that was there would improve the productivity of the soils, but also significantly absorb carbon from the atmosphere. Not widely enough known, but there's many, many times more carbon in the top 2 meters of soil in the ground and in plants than there is in the atmosphere. So if you can increase the carbon stock in plants and soils by 10%, the leverage of that in the atmosphere is many times 10%. So it's a big opportunity, and lots of different technologies. One that I've taken interest in, so much interest, they made me patron of the Australian Biochar Society.
Oh, fantastic.
And we had our first conference in Hindorf in South Australia recently. But the idea of, it's in its early stages, but I think it'll be a very big deal. You take any form of biomass, could be household waste, or it could be agricultural waste, like those millions of tons of bagasse you get left over when you squeeze the sugar juice out of it in Queensland, or it can be the waste from sawn plantation timber that's left on the ground to rot and turn into methane in the plantations of southeast South Australia and southwest Victoria, or it can be trees planted for this purpose, and you absorb carbon in the trees while they're growing, and then when they've reached the mature age, you cut them down, put them into pyrolysis, and plant another tree to do it all again. Well, if you pyrolysis turns the biomass, it releases the water, a lot of water in biomass, and leaves you with a carbon, a pure carbon and a hydrocarbon. The hydrocarbon is a fuel or a raw material that replaces oil or natural gas or coal. But the char, the pure carbon, if you put it in the soil, it's as close as we can get to permanent sequestration of carbon in the soils. This is recognized by the IPCC, first used on a large scale by the Amerindians in the Amazon. They used to improve the productivity of what had been leached and poor quality soils by putting a lot of charcoal in them, and over the years improve productivity, but the carbon stays there, permanently sequesters it. And you can feed a bit to cattle and it improves the digestion. And what methane from cattle or sheep is wasted food. They belch out hydrocarbons that could be digested and turned into meat or milk or wool, and improves the digestion. And when they get rid of it with their excrement, then it stays there as carbon in the soil. And Bill Gates will give you a very high price for that credit if you can demonstrate the cow crap has ended up on your ground, because it's permanent sequestration, negative emissions. So there'll be lots of technologies. I have got a fair bit of sympathy for starting with a technology that's proven, a technology that's been working successfully for about 1 billion years, called photosynthesis.
Indeed, yes.
Taking carbon from the atmosphere, solar radiation and water, and turning it into biomass. And then
it's got a pretty good track record, hasn't it, Ross? It really does.
We know it works. So,
exactly.
Now, there's a lot of others, and we should, as I said before, we should be looking at all of them. But let's give its due to a proven technology, photosynthesis.
Great, good. Look, we've got a cascade of questions here, Ross. There's one I can't resist asking you. You don't have to answer it. I think he's a bit of a stock market person and a gambler as well, by the sound of it. He says, when I win Powerball, Ross, which of our superpower industries am I going to invest in?
Well, this is not the ABC, so I could mention.
Yes, you can. You can say what you want.
Energy is doing very well, although it's just a private company. Yeah, I think that in the energy sector, companies that understand and are 100% committed to the new technologies, it's quite hard for the companies that started on coal and gas to transform themselves. So look for the pure plays in the new technologies. This is not an unusual thing in business for the established players to find it hard to change. A generation ago, IBM produced most of the computers on Earth, and they probably employed 3/4 of the really clever electrical engineers working on computing. And if someone had said in 1980, in 40 years' time, every desk in every office and every house is going to have a computer in it, which company is going to succeed? Everyone would have said, well, there's only one, it'll be IBM. With 5 different sets of kids in garages in Massachusetts and California, invented the new world and made it happen, and IBM became much less important than the pure plays in the new technology. I think that the early stages generally, I've already mentioned that the very first players in a completely new technology, the energy is no longer new. It's a matter of doing it well and cleverly. But for the new industrial technology, zero emissions, like zero emissions iron, zero emission fertilizer, and so on, there's still experimentation. And so those who are right at the forefront will spend a bit of their own dough on learning and then everyone knows once they've learnt it. That's why we need systematic policies of government support for the innovator. Take it away once you've got a few. Once we've got 3 green iron plants, we'll have all learnt, and let the new. But the government needs to support the early ones. Same zero emissions urea, first users of the new technologies. So for your questioner, for the industrial technologies, wait and see whether this new government in Australia systematically supports innovation, and if they come in with general systems of innovation, that'll be the time to back the new industrial technologies. Now, Joe Biden's done that in the United States. This new legislation makes the government's there making a very big contribution for innovation, for example, anything to do with hydrogen. So if we had similar policies, then it'd be right now to back the new industrial technologies. But we need another step or two of progress in the policies to support innovation. I think that Ed Husick and others, Chris Bowen and their departments are thinking about these things. So quite possible we'll get there. We don't have to get there Joe Biden's way. There are other ways of doing it. But I think that the time to make the big financial commitments is when you've got that policy regime in place.
Yeah. Look, Ross, just turning to the Inflation Reduction Act, I mean, one of the most striking aspects of it was that $3 a kilogram subsidy, I think it was, for hydrogen, if I'm correct, which was bringing hydrogen down to a cost competitive, green hydrogen that is, down to a cost competitive level with a lot of other energy. And one of the companies I've been keeping my eye on is a thing called Solar Foods. I don't know whether you've heard of these people, Ross, in Finland, but they use hydrogen, green hydrogen, to feed a particular kind of bacteria, which I was unaware of, a thing called canal gas bacteria. These are hydrogen feeding bacteria. They're only discovered in the 1990s. They breed extremely rapidly. They've got to be harvested 8 times a day, and they produce a protein powder, 60% pure protein powder, which is tasteless, which can be mixed in with any other protein source to replace soybeans or whatever else you want, as sort of an extender to feed the world. And that was so left field for me to think that hydrogen might be used directly to produce our food that I was astonished. And I don't know where you stand with this, Ross. Do you think we're going to keep seeing these amazing opportunities and pathways open up into the future? Were you just at the beginning, or are you getting towards maturity?
Well, I haven't heard of that one either.
No.
When anything breeds that quickly, you have to worry about it taking over the earth, like rabbits took over Australia.
Indeed. But they have been around for 1 billion years, so they know their place, and they've got to have free hydrogen to be able to live.
Oh, no,
You're right.
Well, that's a good constraint. They're much easier to control than rabbits in that case.
Yes, indeed.
No, I think we're going to go through a period, a generation or so, of rapid innovation. Actually, a very good time to be a clever young Australian educated in the applied sciences and taking an interest in these things. Wish I was going to see it, Tim.
Look, I reckon you'll see quite a bit of it, Ross. You've got to hang around for a while.
No, we've already seen spectacular innovation in the last decade. Despite the fact that we've had an incoherent policy regime and put in place systematic support for the news, and it won't go on forever. This is a transformation that will keep going until the world's got zero emissions. And if that's done by 2050 for the world as a whole, which means earlier than 2050 for developed countries like Australia. If it's done by then, we'll hold temperature increases with a bit of luck to 1.5 degrees. We'll probably want the Australians and humans of those days will probably want to go to negative we will have mucked up the world a fair bit at 1.5 degrees. They prefer not to have flooding three times in a year in Lismore, and multi-year droughts in the Murray-Darling. But it won't go on forever. Very rapid innovation in the next generation, the next 3 decades, then we'll find the action moving to other things.
Yeah, indeed, Ross. Look, question's come up that puts this in context a little bit. We are in a race, aren't we? We're developing these new technologies, and yet our world is climatically destabilising. And the question is, given the world is now 1.2 degrees hotter, is there a practical way that the world can draw down carbon emissions, which is fair enough? But to answer the question, I think we've got to go to Malte Meinhauser's chapter of your book and just look at what that trajectory is. Do you think that systemic risk is destabilising climate to such an extent we won't have the capacity to transform? Or do you think that where do we sit with that?
Yeah, I don't think it's done that yet, Tim.
No.
And if we succeed in getting to zero emissions by 2050 and 2045 for Australia and America and Europe and Japan and Korea, and 2055 for medium income countries, currently China, but they'll be high income by then, so they'll have to do it with us. And then poorer developing countries like India, 2065, but averaging overall net zero by about 2050. If we succeed in that, then most of the warming we'll ever have has already happened. 4/5, 80% of it's already happened. Now that's a very uncomfortable 4/5. The increased variability of rainfall, the longer and more intense droughts, the greater severity of drought, because in a warmer climate, the moisture evaporates more quickly, more intense rainfall events when they happen, so you get more flooding. 1.1 to 1.2 degrees, we're in that range now, is very uncomfortable. But if we succeed in zero net emission for the world as a whole in another 28 years, then the odds are it's just a little bit worse. Now, as I said, it's bad enough for our successors on this earth to say that Tim and Ross buggered it up. We better reverse some of that and draw down from the atmosphere. So I think the drawdowns are going to be very important, but I don't think we should be too pessimistic. And the interesting thing about Meinhausen's chapter, Malte has been working on these issues, great atmospheric physicist, one of the leaders of in this field, and very influential in the IPC and the UN's development of its basic strategy. But Malte's always been, to my taste, rather too pessimistic. But by inclination, I always want to play till the final siren, and you might be a bit behind, but you keep having a go. And Malte in the past would say, I don't know if we're going to be able to do it. Well, in his chapter this time, he's saying the reduction in the costs of renewable energy and other zero emissions technologies have happened so fast that actually, he says, I think we're going to do it. So that's terrific.
You're quite right, Ross. And look, I'm with you in terms of the optimism, but just to dig down into Malte's chapter a little bit, I mean, he does say that, I think it's all 5 scenarios of the IPCC 6, so the most recent IPCC report, show us reaching 1.5 degrees within the next decade or so. Regardless of what we do, there's no way we can avoid that. And it looks like we'll continue on, given current pledges under the Glasgow meeting, to 1.8 or 1.9 above the pre-industrial average before we start drawing down and getting back to 1.5 later in the century. So there's a sort of a period of peril, I think, ahead, and it's very. I don't know whether you caught it, Ross. There was another article published in Nature looking at the tipping points, saying at 1.5. I think it's 5 of the 23 tipping points that have been identified go from being possible to likely at 1.5 degrees. So there is a degree of uncertainty around this, the science that leaves me a little bit uneasy. And although I'm with you playing to the siren, I do worry about some of those warnings.
Oh no, quite right to worry. And if there was any point in worrying, I think I'd spend more time doing it. We could. There's a serious risk we won't quite make it. And when a big country like Russia and a big emitter of greenhouse gases like Saudi Arabia is really not playing in the game, that's pretty serious. Although Russia did put on the table that commitment to zero emissions by 2060 last time. Well, who knows what the dynamics of their commitment will be following the mess in Europe this year. But there's a serious risk, and the best thing we can do is run as fast as we can. And as we succeed in making progress, take that as encouragement to go even faster. And I've always felt that. I said this actually in my early report, that but if you set an ambitious target and start to make progress towards it, that can give a community confidence that it can do more. And that is how the Paris Agreement was structured. All of those national pledges, they didn't add up to 1.5 degrees or 2 degrees. But the idea was that every 5 years, the countries would come together and assess where they were at, put pressure on each other. And every developed country except Australia improved its 2030 commitment between Paris and Glasgow. We didn't, but next time we will in Egypt. And when you're making progress, especially when you see you're actually doing well economically by making progress, that makes it possible to go faster. And I like that bit of the structure of the Paris Agreement, that you don't try once for all to say what your targets are, but you recognize we're not getting far enough. And so periodically you all meet, put pressure on each other and do better. That way, it's still risk. There are some things that might happen that'll be horrific. But if we keep taking every chance to accelerate, if Australia goes quickly to supplying that 8% of global emissions reduction, then that'll improve the odds.
Indeed. Look, we've got a couple of great questions come in about our renewable energy situation here in Australia. So I'll give them to you together so you can pick and choose a bit. But one asks, would an overall regulator of renewable energy project development be better than just individual project approval? So that's the first. The second one is, would the Sun Cable network be better to send electricity to the east coast of Australia via a new transmission network rather than to export it overseas?
Well, I think we'll meet the needs of Brisbane, Sydney and Melbourne by shorter transmission lines of the kind that are now being discussed between the state government and the Commonwealth government. I think we'll get there. And I think we'll be able to decarbonise what we've already got more cheaply than putting in a big cable from the Northern Territory. But both Twiggy Forrest and Mike Cannon-Brookes know how to make a buck. And I think they've worked out that Singapore was a better bet than Sydney and Brisbane. And I presume that one reason for that was that they could see that places closer to Sydney and Brisbane would be able to do it more cheaply. So I think let's do our own decarbonisation to zero as quickly as possible. I'm very encouraged by announcements we've seen really in all states this year. Well, New South Wales had already put very strong policies in place, the renewable energy zones out to the Central West Dubbo, out to the New England. and a lot of very sensible state support. And that now, I noticed in today's papers that the Treasurer, Matt Keane, requesting Commonwealth support from the Rewiring the Nation policy to accelerate that. In Queensland, a very coal-dependent state historically, and that big energy plan announced by the Premier a few weeks ago effectively has coal generation for domestic use going down to pretty well zero by 2035. South Australia got rid of its coal a long time ago, and now instead of having much more expensive power than Queensland and New South Wales has cheaper power. WA, my home state, I keep in touch with the ministers and the Premier there on their programs, and there was a big question of what would happen to the jobs in Collie, the coal mining and coal generation centre. The Premier in Collie announced the phasing out of coal by 2029 just a few months ago. So now, for all that to work, you need the new transmission, but the Commonwealth is working on the states for that, with the states for that, and you need a lot of regulatory change, but everyone now understands the need for it. So I think we're going to get to zero emissions electricity by about 2035. And that's pretty good, and that's the base for decarbonisation of a lot of other things, so that projects like the Northern Territory to Singapore project can start the job of getting us to reduce other countries' emissions.
Yeah, look, that's right, Ross. I remember that Collie plant you were talking about, reading that the most the newest coal-fired power plant in Australia was being fed from that coal. So when they start closing the most recent ones, you know that things are changing. But look, Ross, could I just finish? We're nearly at time. I just wanted to finish by thanking you for a completely masterful overview of an incredibly complex subject. There's so many things we could have explored in your book. I'm sure the questions will keep pouring in after we finish speaking. But it is such a timely book, such an important book for our country. I can't recommend it highly enough. I think, indeed, thank you. If the first one sold 20,000, this one should sell 50,000, Ross. It really is quite a vital read for everyone. So could I thank you for being part of this evening? You've been fantastic. We're going to go now. I think there's going to be a wrap up, but it's been a privilege being with you, Ross. It's been wonderful. Thank you.
Thanks, Tim, and thanks for all you've done starting before I got into the game.
Oh, no worries. And thank you to all of our wonderful questioners. We'll see you later.